degree angles, and we looked at our radian angles, and then we talked about standard position. And so now we want to label a bunch of angles that are in standard position. So remember, standard position means that we're starting on the positive x-axis, and we rotate counterclockwise. I've given you a handout that is called the unit circle. Basically, we started with angles. Next week, we're going to look at some sines and cosines. And all of that is kind of just like the foundation or the basics for things that we need to know for all of the other stuff that we're going to do this semester. And we need to be able to remember it. So your unit circle is kind of like a handout or like a graphic that can help us put all of that information in one place. So that way we can remember it easier going forward. So today we're going to work on labeling all of the angles on your unit circle. We do need to label them both in degrees and radians. So remind me, yesterday we talked about that one full rotation is how many degrees?
360.
Okay, and we said that that is what in radians?
2 pi.
2 pi. Okay, but we were then able to reduce that because we can reduce both of those by 2. And we said that 360 divided by 2 gives us 180, which is equivalent to just pi. If I take that in half again, what is half of 180?
90.
90. And what is a half of a pi?
That's half of pi.
Pi over 2.
Pi over 2. We just write it as a fraction. It's a half of a pi. Okay? If I were to half that again, what is half of 90? 45. And what is a half of a half?
An 8. Or a 4.
A 4. So we have pi over 4 is going to be directly in between those two. Okay? Hopefully all of these angles are sounding slightly familiar. So 360, 180, 90, 45. All of those are some of our special angles that we learn in geometry. The last two are our 30 and our 60 degrees. And those are going to be equivalent to pi over 6 and pi over 3. Okay? Now, like I said, these are all of the special angles that we have, but we need to start putting them on our unit circles so they're all kind of nice and pretty and easy for us to remember. So we're going to start with our degrees. So those are going to be the little blank that is the farthest inside the circle and has the little degree symbol on it. So remember that we start at our x-axis. So if I haven't moved anywhere, and you're just still on your x-axis, you don't have an angle, you have like nothing basically. So you have a degree measure of 0. Then we talked about that our 3 special angles are 30, 45, and 60 degrees. Yep, almost 30. Then we also discussed going all the way around is 360. Halfway around is 180. Half of that is 90. Do we know what our negative y-axis is? 270. Now, at the end of the day, our goal is just kind of to remember all of the angles that we're going to put up here, but I am going to show you how we can find all of them if for some reason you forgot one. So we really have to have this first quadrant memorized. There's not really a way around that. We have to remember that we have 30, 45, and 60. But from there, as long as I can remember those, we are able to find our other angles. So notice that if I look at 30 degrees, okay, this is what we call our first quadrant. And just like as we go with our angles, we go counterclockwise, we also go counterclockwise with our quadrants. So over here, going to the left is our second quadrant, bottom left is our third, and bottom right is our fourth. type of relationship does my 30-degree angle and that angle have? There's a right angle in between them, yes? So I could also just say, well, if I know that this angle is 30, and I know that this angle in between them is 90, then what does this big angle have to be? 120. I can just add 90 to my 30 degrees, and that gives me 120. I can do the same thing for my middle angle. It will also have a right angle with 45, and I will have a right angle with 60. So if I take 45 and add 90, what do we get? 135. And if I take 60 and add 90, we get
150.
150. So those should be our three angles in our second. Now notice that I can do something similar. If I go all the way across, what type of angle is going to be created there? A straight. Okay, so what degree angle is that? 180. So now we can take each of our original angles and add 180. So what is 30 plus 180? 210. 45 plus 180.
225.
And 60 plus 20.
240.
Okay. Now, for your last one, you kind of have a couple of options. One, we can add 270 to each of our original three. I can add 180 to each of our seconds, or we can add 90 to each of the thirds. Yeah, so our first angle in the fourth quadrant will be 300. Then we have 315 and 330. And again, lastly, going all the way around is 306. Questions on that? Okay. But as we said, we have to have degrees as well as what? Radians, or stuff with pies, yeah. So that's why you also have a second little blank on the inside, okay? And that's for your degree, for your measurements in radians. Now, luckily, 0 is still 0, even if we're in radians. So that was pretty
Does that mean our key lines are the same? Like this one's 70, or not? No,
So we labeled a couple of them. So remember that going all the way around was 2 pi. Halfway around was pi. We said that half of that was pi over 2, and then half of that was pi over 4. We then said that we have a 30 and a 60 degrees. Those are pi over 3 and pi over 6. Do be careful though, because remember that the bigger the denominator, the smaller the fraction. So pi over 6 is going to be our 30-degree angle, and pi over 3 is our 60-degree angle. People really want to like switch those. So again, we have to have this first quadrant memorized. However, we can kind of do the same thing we did with our degrees to find the rest of our radians.
Will the next one be?
So again, we said that a 90-degree angle is created in between my first and my second quadrant. But what is 90 degrees in radians? Pi over 2. So I'm going to take my pi over 6 And just like I did with my 30, right? We took 30 plus 90. Now I'm gonna take pi over 6 and I'm gonna add pi over 2.
Pi over 3.
We have, so how do we have fractions when we add them? How do we add fractions?
Butterfly.
No.
2 power.
We have to have a common denominator.
So
So I'd have to multiply my second fraction by
3.
3 over 3. So we get,
3 pi.
so I have 1 pi, and I add 3 pi's, so we get
4 pi.
4 pi's,
4 pi over 6.
which also reduces to
Or 1 pi.
2 pi over 1.
2 pi over
2 pi over 3. There we go. We can do something similar with our pi over 4. So what's our common denominator between 4 and 2? 4. So we would have pi over 4 plus 2 pi over 4, which gives us
3 pi
3
over 4.
pi over 4.
So it's just 3 pi over 4.
Yeah, that one doesn't reduce. Okay. And then I'm taking pi over 3 plus pi over 2. What's our common denominator for 2 and 3? 6. So we would have 2 pi over 6 plus
2 pi
3 pi over 6, which gives us
5 pi
5 pi
over 6.
over 6. Now what do we notice about our numerators there?
They're the same as the first quadrant.
They don't
Our
like 5.
denominators are the same as the first quadrant, yes. But what about our numerators?
The one that comes after it within, like, going counterclockwise ends up on the top of the one before it.
Meaning that like we ended on a 3 for our first quadrant, so we started on that 3 for our second quadrant? Yeah. Agreed? And that's actually gonna be true all the way around. So whichever one we end on, so like we ended on a 6 for our second quadrant, so we are gonna start on a 6 for our third.
So the bottom's gonna be 6 or the
It's gonna have a 6 originally, yeah. But what's the relationship between the numerator and the denominator for each of those?
plus 1. Or there's a 1 difference.
Yeah, the top is gonna be 1 smaller than the bottom, right? Which makes sense because 1 pi, my fraction is 1, yes? So we're getting closer and closer to 1. So the top is just 1 away from the bottom. Okay? But now, if I'm bigger than 1, what are the tops gonna have to be?
Next number.
Yeah, an improper fraction, right? Where the top is now gonna have to be bigger than the bottom. And we can find those by same idea, right? I can take my pi over 6, but now I'm gonna add pi. So what's our denominator if I just have a pi?
1
Okay, so my common denominator would be,
6
so I get pi over 6
plus 6
plus
pi
6 pi over 6, which gives us
7 pi over 1.
7 pi
7
over
pi over 6.
6.
Miss Bennett, can I go to the bathroom?
Yes? Our pi over 4 would work the same way, right? I'd have pi over 4 plus 4 pi over 4, which is going to give us 5 pi over 4. And then lastly, we would have pi over 3 plus 3 pi over 3 gives us
4 pi over
4 pi over 3. So what's the relationship between our numerator and denominators this time?
That is this.
One bigger this time, yeah? Alright. And again, lastly, we could either add pi to our second quadrant, or we could add pi over 2 to our third quadrant, or what's this bottom angle gonna be where my like 270 is?
Wouldn't it be 2 pi?
Not too bad. So I've gone 1 and a half the way around. So what's 1.5 as a fraction?
4 pi over 2. Or
Not quite.
3.
2.
3 pi over 2. Okay, so you could also add 3 halves to each of the first. Yes? And whichever way you do it, you're going to end up with a 5 pi over 6. Sorry, 5 pi. 5 pi we're getting closer and closer to 2. So notice that we're getting closer and closer to double the bottom, but it is 1 away.
Can I go read them? I want to.
Yeah. So again, our goal is at the end of the day, we just kind of need to know these. But if you ever forgot one, you always could go back to, okay, I can add pi, that sort of thing. But like we said, it's also helpful that we can remember if I end on a denominator of 3, that's what my next quadrant has to start on. Or if I end on a denominator of 6, that's what my next one has to start on. Our second quadrant is 1 less than the bottom. The third is 1 more. And the last is 1 less than double. So if I double the denominator and subtract 1.
Is that 11?
Yes?
Wait, 9.
Yes, if it was 11.
Oh, I heard 9. It was very My brain hurts.
Alright, so you want to make sure that all of those have been labeled on your sheet. And like I said, we will continue to add to these over time.